Hello. So we are back, and this time we have a job which is coming from a computer shop, kind of local. But anyway, this is a beautiful laptop. Yeah, it's more than nice. So check here, Acer Predator, 10 Gen RTX graphics, 17-inch screen, 240 Hz screen. This is a proper gaming machine. And you have a turbo button. What this is doing, customer said he is believing is the BIOS. That's what he said. Pressing the power button, nothing happened. Let's plug the charger. We have the charger on screen. Plug in the charger. No current. Pressing the power button. No current. This is no BIOS. So it's taking nothing. I'll check the charger. I'm not sure about my charger. Let's see. Just want to be sure because it's confusing when they said something and yeah, the voltage is right. So the laptop is not coming on. Let's open the laptop. Okay, was some things on the back. I have to cover them, but now I see some note here. My customer made a mess replacing thermal paste and in doing some burn out a component. I have done nothing and I have done not anything to this laptop. I have not done anything about this laptop. So it looks like this is a cause fault. A cause fault is different compared with like a regular fault when has a logic. A regular fault always have a logic. But a fault which is caused has no logic. I mean, you can have a knockout component from the board. You will never find it. That's the thing. So cause faults are harder to fix compared with normal faults. So the back cover is out. Does blow up? It's a really mess. I mean, everywhere it's a mess on this board. Oh wait, it's a sticker. Okay, got it. So he used a sticker to indicate that's a blow up thingy. Haha. Okay, so maybe I misunderstood. Maybe this one is not with the BIOS. No, not this one. He gave me more laptops. Okay, clearly that's a blow up Mosfet, right? I mean, how blow up it is? Is shorted or just interrupted? So let's check the main power rail. It's interesting, the battery is still plugged in. Let me unplug the battery. Yeah. So let's see. The main power rail shorted 22 ohms. Why the main power rail has 22 ohms? Because this coil to ground has 0 ohms. Lol. Okay, that doesn't make sense. So this coil to ground, 0 ohms. So whatever is on this coil can be VRAM, can be GPU. No, if it's GPU is fine, but it's not the GPU. The CPU. Probably is the CPU. Probably is the CPU. Because the CPU is next. Well, let's take the heatsink and have a look. I mean, just, for our information. Okay, so the heatsink is out. Let's remove that Mosfet quickly. This is proper stock here. Yeah. Yeah, this is welded. But still good. Okay, let's check now. So main power rail is not shorted anymore. And from here to here we have 0 ohms. Yes, whatever is here is 0 ohms. Now what is there? Let's check the CPU. CPU, 1 ohm, that's not good. 1 ohm, 1 ohm, that's not good. 1 ohm, okay. And this one, 0.06. And this one is going where? Can be the GPU. But yeah, this is dead. This is dead. You know what I mean? Dead. Let's see, plug in the charger and it's taking, check there, 150 milliamps. So most likely the IO chip is dead shorted. Because I cannot see from where it's taking the current. No, it's not, it's alive, lol. It's alive. But still curious, you know, what is taking that 150 milliamps? That's a good question. Actually, it's a very good one. Let's put the heatsink and let's try a small trick. Can we do tricks here? Okay, so we put few screws. Now let's try one more time. 130 milliamps. You know how curious I am what is taking that power? You have no idea. Because something is gone. It's not supposed to take any current when it's off, and the battery is not plugged in. But let's press the power button and let's see what is happening. So basically nothing happened, right? Yeah, nothing happened. I mean, it's dead. Good. Fine, let me grab the original charger. Okay, so I got the original charger. Let's try a trick. Yeah, it is coming on with the original charger, which is good, yeah? Let me power off. Good. Let's come with the power supply. With the power supply, with 0.9 volts, lot of current. Let's come exactly on that coil. Pressing the power button and it's taking for, wait, no, the laptop is on, It's taking 4 amps on that power rail. 4.4 amps it's taking, and the voltage like 0.06. And it's doing nothing, because whatever is on that power rail is dead. Nothing. So exactly on that coil, I'm coming exactly on that coil. 0.6 volts, 4.4 amps. So I'm not even curious what is on that power rail. Probably it's the CPU, or the VRAM, or the GPU, whatever it is dead. Okay. Can't fix it, sorry. Nothing what I can do. Bye. Hello, so we're back, and this time we have a job from a local repair shop, Lenovo. So what happened with this one? They said, he said they found a blow up Mosfet. he replaced the MOSFET blew up again. So what he did, he bought, you can see here from like another 2 MOSFETs, and he sent it to me. So we have to figure it out why the MOSFET is blowing and how we can fix it. I mean, I can't see how the MOSFET can blow. I'm sorry. Basically, you are using a power supply, obviously. So with a power supply, you have a current limit. So it's no way a MOSFET can blow. Right? I mean, that's what we are doing. We are working safe with a current limit power supply. So let me open this quickly. It has no screws. And that's the board inside. That's the all-in-one computer. So one more MOSFET it is. Can you see any MOSFET around here? Where is the MOSFET? Let's take out the heatsink and have a look there. Oh, those are like classic MOSFETs. Why anyone need to buy something like that when you can get them from the board, from any motherboard? So if those MOSFETs looks like this, yeah? From where the MOSFET blow up, you know what? Let's plug the power. I can see this has like a round normal Toshiba pin. Let's diagnose this first. I mean, I cannot replace like blindfold parts from a motherboard. Yeah, it's Monday morning. Fixing a Lenovo is not a good start. I know that. You know what? I don't have a charger for this. So the middle pin is very, very big. So I will get a power supply. So with the power supply, we have ground anywhere, 19 volts. And plus, let's see, so plus is going here. Yeah, plus. And the short, you can see on the screen, 3 amps. The voltage get dropped to 2.5, so probably the short is after the first 2 MOSFETs. Let me grab the thermal camera and have a look. Okay, so coming with current. And I can't see anything. Oh yeah, oh yeah. So what is there? Here. Yeah, this one is getting mad hot, this coil. Okay, so I can assume the MOSFET is either on the other side of the board or under the Wi-Fi card. No, it's on the other side of the board, so we have to take the board out. Let me take the board out. Okay, so the board is out. Let me remove this. So that's the board. And on the other side, I can see some flux here, but I can't see which MOSFET was replaced. Okay, so I assume if this coil is getting hot, then must be those MOSFETs. Let's have a look on the microscope. Indeed, looks like someone worked here. Let's go with some current, just to be sure. So what do we have here? Here we have the big power rail, this one, yeah? Look at chip there. So someone play with the current here. You can see that chip? Yeah. The resistor is chipped. So the plus is coming here and it's coming here. And here, the voltage is 1.7. Okay, the voltage is quite high. Let's check with the thermal camera. So with the thermal camera, indeed, we can see that Mosfet, which is getting hot. So it's the first one. Yeah, this one. Yeah, this one. Now let's remove the Mosfet and try to understand what's going on here. So we remove the Mosfet. Let's check with the multimeter. So with the multimeter, indeed, the Mosfet it is shorted. Now what about the other Mosfet? The other Mosfet has 0 ohms, you can see. So the Mosfet it is shorted. Now this will be an interesting case. And I'll tell you why. It's because the customer, like he said, probably he replaced both Mosfets. That's the reason why he sent me 2 Mosfets. And the Mosfets blow up. So what is the reason why those Mosfets blow up? I'm checking the other power supplies. They have the same Mosfets. So here is plus. Here is the common point. Where is the coil? Let's check the coil to ground. So testing the coil to ground, 1 ohm. So that can be a reason why the Mosfets are keep blowing up. What do you think? Can be a good reason. So let's leave the Mosfets on one side and try to focus what is on this power rail. So what is here? Why this has under 1 ohm? Coil to ground, 0.091 ohm. Yeah, this is the output. This is the output. So we have to come with the power supply there and find out what is shorted. Always, when you replace MOSFETs, just check the output. So I will lower the voltage on the power supply down to like 0.8 volts. Now we staking 2.6 amps, that's fine. With 2.6 amps, we should be able to figure it out what is wrong here. I'm curious, this is not the RAM power supply because it's close to the RAM. Yeah, we don't know yet because the board is too hot. No, it's not the Wi-Fi card. No. The chipset? The chipset is there. I can't see anything to get out. Let's raise the current to 4.4 amps. Let's see now. I still can't see anything. And when you are not seeing anything, it's a problem. Because that can be something like CPU, which is absorbing a lot of heat. Let me remove the CPU heatsink. Okay, so the heatsink is out. I don't think this have anything to do with the chipset. I don't think that. Let me remove the RAM memory. So we are pushing 4.5 amps. The CPU is looking decent. Let's turn around the board and check on the other side. I don't think it's the point. Yeah, so check here, yeah? This track is coming from the other side and is going straight to the CPU. Wow. But I will come with current here. Still, I will come with current here. I will raise the current to 5 amps, yeah? And still I can't see anything. I can see this area is getting hot because we are sending the current through the coil on this point. But it's nothing else. Let's go back to the other side of the board, because that power rail is going straight to the CPU. This one. I mean, for the CPU, like 5 watts, how much we are pushing now, it's not a big deal. It's not a big deal. But from what I can see, it's getting slightly warm. Okay, let's remove the CPU and see if we can, if still is getting current. You see, this is beautiful. You can remove the CPU. I can't believe actually this removable CPU comes from Lenovo. Coming with current here, you can see. So actually it's not taking current without the CPU. So this removable CPU is shorted. Putting back the CPU, check on the screen. Yeah, shorted. 5 amps doing nothing. Yeah, so that's the reason why this motherboard is dead. Probably the Mosfet got shorted and sent the whole power from the charger to the CPU. Now I don't know what to do. Let me speak with the customer. But yeah, he has to buy another CPU. So see you soon probably. Hello, so we're back, and this time we have a customer job. This laptop comes from a computer shop. This is a nice Asus VivoBook, i7, Iris graphics, a nice keyboard. Anyway, the problem with this one, the customer is saying, like the battery connector is ripped off from the motherboard and it's not coming on. So let's open this quickly. Let's have a look inside if we can fix it. Wow, that looks bad. I mean, check that, check there, check there. I mean, what happened there? What do you mean the connector was ripped off? I mean, there's no connector on the battery. This looks like a long job, I swear. Now, this is not my concern. My concern is why the laptop is not working with the charger. So let's try to figure it out. Let's check, because, you know, if someone play with the wires, yeah, on this connector, if they play on the data lines, most likely the EC chip is dead. Let's check the main power rail. The main power rail is good. That's good news. Yeah. Let's plug a charger and try to figure it out. We plug the charger and it's taking 160 milliamps. What do you think is taking 160 milliamps? Huh? Just tell me. 160 milliamps is taken 100%. You know, I'm quite 100% on this one. It's taken by the 3.3 volts power supply, which is supplying the LDO voltage for the IO chip, and the IO chip is shorted. You have to trust me this time, just because someone play on that connector. So check there. What is there? Huh? Why that chip is getting hot? And you'll say, sorry, that chip is burned. It's getting hot. Which one? This one? Okay. Oh, wow. That's hot. Okay, let's move closer to that chip and try to understand what's going on there. So like how I said, this is a 3.3 volts power supply. So what we can check? We can check with multimeter to ground, yeah, compare with ground. Whatever capacitors we have on those power rails, yeah? So here is fine, no short. Here is fine, no short. Here we have 0.7 ohms. Do you think 0.7 ohms is fine? So do you think this power rail, which has 0.8 ohms, this one is good. This one has 0.8 ohms. Why do you think that one has 0.8? That one which has 0.8 most likely is the 3.3 volts power rail. Yeah. So why do you think what do you think is shorted there? Just a wild guess, huh? What do you think? Let's see together. So we are coming with the power supply, ground. I'm using low voltage. Let's see. So on the same capacitor, taking 2.5 amps and wait, nothing is getting hot? How this is possible? No, something should get hot. Something should get very hot. Something is warm there. Something is warm there. Let's check that coil. Let's check that coil together. 0 ohms, yeah? So this most likely is a 3.3 volts power supply, and you know what happened? You know what is happening when you come with the current and nothing is getting hot? What do you think it happened? So when you come with the current and nothing is getting hot, the heat is getting dispersed. I mean, the heat is getting evaporated because most likely the heat has a heatsink. Whatever is getting hot has a heatsink. So check there. Yeah, that's a dead chipset. I'll take the heatsink out. Okay, so the heatsink is out. We are still using 1 volt. Here, taking 2.7 amps. And what do you think is the problem? What do you think is the problem? That chipset. So this chip, which is providing 3 volts LDO, 5 volts LDO, also is providing 3 volts and 5 volts, 3.3 for the chipset and 5 volts for the USB. Yeah. So the 3.3 is shorted because the chipset is shorted. Yeah, sadly, I cannot fix, I cannot replace the CPU. What can I say? I'll say thank you for watching. Like and subscribe if you like the video, like always. And see you on the next one, yeah? Bye. Hello, so we are back, and this time we have a different kind of job. So we have a customer, he sent me two things to repair. I don't know what they are, but looks like are some automatic ignition system. I believe probably are from for heaters, gas heaters. Yeah, probably. Now, how we can fix something like that? That's the question. Is like we have no schematic, nothing. We don't know how they work. So they work with 24 AC. Good. Oh wait, no way, no, I don't think something like that. No, no. So it's an ignition. That means it's a spark. So that means this thingy probably has over 20 kilovolts in order to. No, 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 no. I'm not fixing something like that. No, 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 no. I will get electrocuted 100%. No, this is stupid. This is dangerous. Now I understand what the. Hello, so we are back, and this time we have a customer job. This is a nice laptop. So check here, check here. Huh? 11 Gen i7, Iris graphics. This is a nice one. Touch display, UHD screen. This is a nice one. Let's open and see what's going on with this laptop. Wait, it's another motherboard here. 1 second. I think I remember the job. 1 second. Okay, so the customer bought the laptop from eBay for repairs, yeah? And the owner of the laptop said he tried to install a new BIOS update, he turned it off during the update, and now the Dell is doing nothing. He attempted to repair, he removed the BIOS chip, tried to flash it, but after he reinstalled it, it doesn't not turn on. On power press, orange light comes on and off, no more response. I also bought another BIOS chip from Poland. Tried to install it from the board, but no luck, same problem. Okay, good. So this laptop has like a long story. Yeah, so we have two BIOS chips here. I mean, you know, this looks nice. I mean, the way how it's yeah. Okay, so we have the laptop here. We do have a motherboard for spares. You know what is interesting? Check this board. So probably the customer bought it from, no idea from where, but has no CPU. You can see that. And the RAM is on board, lol. And check that, they stuck the RAM the same like the HP, you can see, with that red glue. Okay, let's open the laptop. Okay, so we open the laptop, lol. Lot of flux here. Okay, let's unplug the battery and do some basic checks before we are actually start doing anything on this board. Good. 1.4 ohms. I mean, I done nothing. I just start with the second coil, 1.4 ohms. That's not good. 51 ohms, that looks fine, 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 Fine. I mean, what is that coil? No. I learn. You know, I'm learning from my own mistakes. So now I'm not starting like blindfold to carry repairs before checking the coils. No, I learn it. You remember that laptop which I spent some time and at some point, oh wait, what was, but the chipset is shorted. Okay. No, I'm not spending. No, I'm testing. This should be like a rule on laptops. Yeah, first you open, you check the coils. That's the first step. That should be the first step, always. You open, you check the coils. Okay, then you move forward. Okay, let's put the ground here somewhere. Yeah, SD card. So we have ground. Let's lower the voltage to like 0 point something. Good. Now let's come with some current on this small coil. And it's taking 1.8 amps. Wow. And let's see what is getting hot. What is there? No, the CPU is there. So it's on the heatsink of the I mean here. Do you think it's on the other side of the board? Let's see what is on the other side of the board. The RAM memories. How a RAM memory can get hot with 0.9 volts? Okay, so this is the RAM memory power supply. Because on that case, the RAM is dead. So we have shorted RAM here? I can't believe. Yeah, the RAM is shorted. What a waste of time. I can't believe. So that coil, look here on this board, yeah? So check here. Check here on this board, yeah? So that coil should have lol, the RAM is shorted even on this board. That's sick. How is possible? I mean, you have the original board, then you have this board, and the RAM is shorted on both boards. I mean, how? .7 amps. With 2.7 amps, the RAM should be mad hot. No, it's not the RAM. Is the CPU? Wait, it's not the CPU. Actually, because the CPU is shorted. Okay, I got it. Yeah, this is fully shorted. Okay, got it. And it's exactly there. It's a solder on the CPU. is here. Yeah, it's a solder here. Yeah, so now it's not short anymore. Okay, so check here. After we remove the short from the CPU, it's taking like 230 milliamps. And on this coil we have like infinite like 13 ohms. Still better, but still looks bad. I mean, even 30 ohms looks bad. Yeah, the laptop is dead. So thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye. Hello. So we're back, and this time we have a customer job. This is a nice Acer laptop, i5 10 Gen and NVIDIA graphics, 144 Hz display. So what's the problem with this one? Well, apart from the fact is that, let's see what the customer is saying. Acer Nitro 5 stopped working suddenly. Won't start, no charging light or either. And the customer tried removing the battery, removing the BIOS battery, still no luck. Yeah, so that's all what we know about this laptop. Now let's plug the charger, which is connected to the power supply, and let's test. So 19 volts, some amps there, and let's plug the charger. We plug the charger and it's taking nothing, zero. I heard a click on the power supply. That's strange. Pressing the power button, nothing happened. You know what? I'm concerned about that click. That click means a lot. Let's show it one more time. It's not clicking anymore. It's not clicking, but that click means a lot. It means that the laptop got more current than I set up on the power supply. Okay, let's open this quickly and have a look inside. So based on that click, I suppose we have a shorted power supply or a shorted power rail. Remember, I always told you follow your power supply, yeah? And keep an eye on the power supply also. Of course, on the linear one. Linear one is clicking because it has a relay. A digital one doesn't. Okay, so the back cover, it's out. And it's looking nice. Look, it's like a classic board. Yeah, it's a classic board. Now let's remove the battery. That's the first thing what I want to check is the main power rail. Yeah, let's remove the battery. Battery is removed. Let's get a multimeter. Now we have to find a power supply. We cannot, yeah, I think even those. Check on the screen, 0 ohms, yeah. I mean 0.8, but my probes have 0.6. So the main power rail has 0.2 ohms. Remember that click from the beginning? Yeah. Now, if the customer is lucky, it's a shorted capacitor. If the customer is not lucky, it will be like a CPU Mosfet shorted. Okay, so we remove the heatsink. So what's the next step? Next step, let's get the thermal camera. Let me grab the power supply. We have the plus and we have the minus from the power supply. We need a ground. And with the plus, we are coming on the same spot. I mean, on the capacitors on the main power rail. Let me lower the voltage. Yeah, let's be safe. Like 0.8, we have some amps there. Yeah, that's fine. That should be fine. Let's see. The CPU or GPU? Yeah, place of your bet. Place your bet. There is something very hot. And I believe that's the VRAM power supply, right? Let's see. So VRAM has 0 ohms. You can see. Gone forever. Yeah, we have that VRAM. So one MOSFET is shorted. The high side MOSFET actually is shorted. It's not like any is shorted. Let's remove the short. Like how I said, the laptop should still work on the Intel graphics. Wait, those are dual MOSFETs. Ah, okay, got it. Got it. So the MOSFET is removed. Do we still have short? Let's check. No, no short. No short. No short. Yes, I will show you. I will show you. So coming with the multimeter, you remember those capacitors? It's not short anymore. Now plug in the charger. Let's plug the screen. Let's clean a little bit. Yeah, we don't need the heatsink. No, it's fine. Yeah. The laptop, it will be fine with my thermal pad. And let's try to power on the laptop and see if we have any picture. 19 volts. A lot of amps. Now let's try and power. Power on. Power on. What? Power on. Let's check the main power rail. Let's check if we have any short on the main power rail. If we have voltage, sorry, if we have voltage. We have like 5 volts. Five volts. $18.8 on the first MOSFET. And after the first MOSFET, we have 0. You think because of my charger? Okay, let's do something else. Let's come with the power supply. Coming with the power supply. Kind of, you know, at low voltage, yeah? I still want to be safe. So on the main power rail, yeah, after the second MOSFET, and it's not short. No, it's not short. No, it's fine. It's fine. Let's come with 19 volts on the main power rail. Let's see. With 19 and it's not short. No. Uh, this is this is a charging thing, I believe. Yeah, let me grab the original charger. Okay, so we have the custom original charger. Let's plug it. Good. Let's try to power on. And I can see the keyboard is coming on. Let's wait because probably the customer reset the BIOS. And we have picture you can see on the screen, and it's loading the windows. Proper hot, proper hot. So, sorry, you fix it. Yeah, this is a working laptop with Intel graphics. Doesn't work with NVIDIA graphics anymore. What we can do? Wow, the GPU is still getting hot. I mean, it's getting hot for nothing, but yeah. We can actually remove the coils from the GPU. Just, no point taking power if it's not working. So, what we can do with this one? Let's see. Maybe we are lucky to have like one dead, but no, it's nothing, one dead. 19 volts around 10 amps goes on a power rail which is supposed to be around 1 volt. But let's see, let's try and see. Let's see which one. Which RAM memory is shorted, huh? So let me lower the voltage. I'll come with the thermal camera. Yeah, it's still hot because we power off. It's still hot because the laptop was on. Yeah, let's come with current. Here on the output of the coil, and it's taking, wow. Let me raise the current. Taking like 3 amps. So check that. You see that one? Yeah. But you know how it is. I mean, I tried before. You remove that one, which is very shorted. And after you remove that one, you'll find another one, and it's a never-ending story. Trust me. Let me see if I have here. Let's check here. So what you'll do is, okay, we have only one video RAM memory shorted. And you'll start removing one by one. You remove one, and then you see, okay, it's not taking 3 amps, it's taking only 2 amps, and the next memory, and you remove the next memory, you see, oh, it's taking only 1 amp because this is getting hot. And you remove this one, then, oh, this one is still taking like nearly 1 amp. Okay, let's remove it. And like how I said on the other videos, people seeing short. Yeah, you see short. Okay, 19 volts came on this power rail, and those are short to ground. No one is seeing, wait, but what about short to data lines? Huh? No one is seeing that. Well, the short is working on the always. So if 19 volts came to, those chips and it goes to ground, short them to ground, also the 19 volts goes to the data lines, which they are going to the NVIDIA graphics. Yeah. So it's not like, okay, the shorts are always to ground. No. Most likely the shorts are always bidirectional. Yeah, it's going on everywhere. But still, we are delivering to the customer a working laptop. So we can still, charge something. We help him. He can use this laptop a little bit more. So I'll stop here. I will say thank you for watching. Like and subscribe if you like the video, so you can see if you have a short like a GPU, VRAM, you remove the short and the laptop still be working on the Intel graphics. I'll see you on the next one. Bye. Hello. So we're back, and this time we have an all-in-one computer to repair. These jobs came from a local repair shop, was booked in today. And this is a Acer Aspire C22-1600. Can we fix an all-in-one computer? I mean, they are like laptops. I mean, even the charger, this is like an Acer charger, like a classic charger. You can see it here. Probably you can't. Yeah. Okay, great. Now, how we are testing exactly our laptops, yeah? So what is important, and I said it many times, it's important to check with uh, with the power supply or with an adapter like how I'm using. But many years I didn't have this adapter. So I was coming with the power supply and just check to see what's happening inside. Okay, let's leave on one side the adapter. I mean, yeah, we can try with the multimeter. It is important to see what's going on inside of the computer. Yeah. So based on this, just plug in the charger. I can figure it out what is the problem. Is dead? Is shorted? Is responding to the power button? Yeah. You have few things you can test. So plug in the charger. Lol. Wait. I had like max current on my power supply. Okay, so what we can see, plug in the charger and it's taking what limit you put. Yeah, it doesn't matter. You can put 5 amps, it's taking 5 amps. And the voltage is getting dropped to under 1 volt. I mean, we can clearly see this is shorted. This is so easy. Even on a computer shop, a customer come and it's important to, okay, I know for sure this is 100% a motherboard fault and that's the price. That's what you want in a computer shop. That's, just to be pro. You just tell the customer 100% it's a motherboard fault. You can say that. Just based on this, you see, plug the charger, shorted. Now this will be a short video. I'm curious how we can open this. I can see some screws here. You can see them? Yeah. Let's try and open this. Now another thing what we can check, and you remember that video, This Is My Secret? You remember that video? Yeah, so what you can say more about this desktop? Here is the screen, lol. Here is the screen. You sure has to be open from here? Yeah, has to be open from here. That's good. Okay, you remember that video? This is my secret, and was about current, and yeah. Let's apply that here. So let's check now. We have low current. We have like 750 milliamps that we can make it 1 amp. Yeah, 1 amp. So it's very simple, based on the ohm law, to figure it out the internal resistance. The voltage is like 0.06. It's not a big deal. And you will say, yes, sorry, it is possible this short to be on the charging port, straight on the charging port, or somewhere on the charging port line. Yeah, can be a short there because the voltage is very low, even with 1 amp. But going up with the current, yeah, check here with 4 amps, yeah, I have like 2 volts there. Yeah, so this is telling you a different story. Like I have 2 volts. If it will be a short here, I will not have 2 volts. So the short is not here. Actually, the short, it's after the first 2 Mosfet, most likely. Most likely, yeah. So let's try to open this. I just explained, just following what the resistance is doing when you come with high current. Yeah, when you're changing the current, but the resistance actually, see the voltage is going up. Okay, still. Oh, okay. Yeah. I think I opened the. How? Huh? I don't want to crack the screen. That's the problem. Why is not getting open? Oh yeah. I found it. Okay, so we open the computer. So check here. Check here. What computer is this one? I can't believe it's like a tablet board. You know what I wish? I wish when the manufacturer is selling a all-in-one computer, I want a picture with the board. That's all what I want. So what do we know? We know this is the charging port, and I can't see. You can see like first MOSFET, second MOSFET, things like that. Oh, I can't see anything. I don't think it's on this side of the board. What do you think? Because the charging port is going on the other side, right? Here you have a diode, and most likely a diode near to the charging port. It's a diode to protect in a case you connect the voltage like in inverse, yeah? Now let's see. So the short is on the charging port? Is not. You can see exactly what I told you. The short is not on the charging port. And this diode, check on the diode, 0 ohms. So the diode has 0 ohms, you can see. So what does it mean? Does it mean it can be a faulty diode and that's all? Because can be something else and you get tricked by that diode. No, it's not the diode. No, no, no. It's not the diode. If it was the diode will get hot, but it's not a diode. But what it is? Okay, that's a good question. Let's try again. Let me grab the thermal camera. Maybe we can spot something from this side of the board. What do you think? So plug in the current. Let's see. So what is getting hot? What is getting hot is my cable, which is carrying current. And something there. Here's something, right? On the other side of the board. Yeah. Clearly it's on the other side of the board. Yeah, so we spot the fault you can see here, but it's on the other side of the board. So we have to open the motherboard and check whatever is here. Now let's take the motherboard out. So what is shorted? Based on the fact this diode show me short, I believe that diode is on the main power rail, and I believe the main power rail is shorted. Okay, so we took the motherboard out. Huh? It's not looking bad, the motherboard, so the heat was where? Here. I mean, somewhere here, right? Yeah. So how we can fix it? If we are checking with the multimeter, like any capacitor, yeah, like this, 0 ohms short, yeah. Checking different capacitor, like where? Like on a power supply, like these ones. No, this is the output. That can be this one. Okay, anyway, let's go with the thermal camera. So I said this is the charging port. But even on this side of the board, I cannot see the first MOSFET and the second MOSFET. I believe those are, but not sure. So let me plug the charger. Yeah, let's plug the charger and check one more time. Plug in the charger. Good. It's still taking current. And what is that? What is this? This is shorted, right? Huh? No, actually that MOSFET is getting hot because it's good. Huh? It's kind of confusing. Like, okay, sorry, that's getting hot because it's good. Yes, that's the answer. Yes, it's getting hot because it's good. You know, when you apply current, whatever has like high resistance, it will get hot. Like on this case, the MOSFET. That's the reason why it's, you know, I always try to identify the first and second MOSFET and come with the current after the first and the second MOSFET. So I believe this is our first MOSFET. And obviously probably it's not shorted here on the input. Oh, it is. Then maybe this is the... Oh, okay. It's shorted on the both sides. How? Let's have a look together. Let's see what do we have here. Why this Mosfet is getting hot? Wait, do you think it's part of a power supply? Lol. Yeah. Let me check the coil. Coil has 1 ohm. The other coil has 1 ohm. Lol. I mean, this is looking bad. You know, it was looking so nice from the beginning. So check now, yeah? This coil, 0 ohms. This one, 0 ohms. Why is it looking so bad? It was looking like, you know, like a shorted capacitor in the beginning. But now we have like shorted MOSFETs. Okay, let's start removing the MOSFETs. I still don't understand what's going on here. I cannot figure it out, the first and the second MOSFET. But this is getting hot, so I'm assuming this MOSFET has 0 ohms, yeah? Okay, let's remove the MOSFET. Let's see what do we have 0 ohms here. Okay, so we remove the MOSFET. Good. Let's check with ground. Do we still have short? Here we don't have short. Here we still have short, like 0 ohms. Okay, let's remove the second MOSFET. Okay, this is the second MOSFET. Let's check for short. So here we have 0 ohms, and here we have 0 ohms. The coil has 0 ohms. This coil has also 1 ohm. It's not even worth to move forward because we have what we have here, a dead CPU, dead chipset. Yeah, the CPU most likely. Let's open before we are coming with the current. Check there. What is that? What's that? That's the CPU? Yeah, that's the CPU. And on the other side, what do we have on the other side? Let's raise the current. 4.4 amps. That's the CPU, right? Yeah, that's the CPU. Gone. Hello. So we are back. And this time, it's Friday. The weekend is coming. So what do we have here? Here we have a nice laptop like usual, but this laptop has a problem. Yeah, so check here. Huh? Now this is the most easiest job ever. Yeah, this is like, you know, easy money. I mean, how much is paid this job to be done? I mean, here in England, it's about £60. With £60, you can get this kind of fault fixed. Can we do it? Yeah, probably we can. So what do you have to do first? First, you have to check the laptop to be sure it's working. You don't want to fix the hinge and actually have a broken screen or a broken cable. So it is working. The fan is not working, so we have to fix the fan. I don't know why the fan is not working. But anyway, let's open the laptop quickly and try to fix it because the weekend is coming and We have to have a coffee together Sunday, you remember? Here is no screw, so that can explain why the hinge got broken. And now we can take the back cover out. Wait, why the speaker is stuck on the back? What is this? Liquid damage. We have to charge double. Huh? No, I'm just joking. You know, the laptop is working. You cannot go. You can tell them, you know what? The laptop has liquid damage, but you can't just, you can't just clean it and tell them, you know what? It was liquid damage, because they will say, no, the laptop was working fine. You know, I brought the laptop for a hinge repair, not for liquid damage. So yeah, of course you cannot do it for free, but we have to be sure this is working. No, it's a old liquid damage. It's old. It's a old liquid damage. But why the what? Oh, look, it's inside. It's something inside of the fan. Check here. Check here. Check here. So here is something. Where it goes? Yeah, this one. It was inside of the fan. So now the fan is working. We fixed the fan. We fixed the fan. That's great. So if we are powering up the laptop, what will happen? So let's power on. Power on. Let's see if we still have the error with the fan. And no fan error. It's loading the windows. You can see, and the fan, it is spinning. You can see it's spinning. So all we have to do is to fix the hinge. This is broken. I mean, we have a lot of damage on the hinge. So check here. Yeah. You can see here the damage. I mean, everything is broken here. And here, this thing is broken. You can see it. Yeah. So can we fix it? Yeah, of course we can fix it. The problem is you have to understand how you can fix this. Let me power off the laptop. You cannot do like things by yourself from, for power from you. You know what I mean? Like, let's say, like the people you remember on the last video. Like, sorry, okay, let's clean the fan. Let's replace the thermal paste. Let's clean the board from the liquid damage. It's the same way you go to the mechanic with the car. Yeah, you go on a service. I say, please repair my door handle. And when you come back to pick up your car with a fixed door handle, you should expect to have a clean air filter. Huh? No, because it's a different job, a different story. Okay? Good. Now, in order this board to be cleaned properly, yeah, we have to take the board out, take everything out, clean everything with water, with, I don't know, some earbud or something. This is a sweet liquid, has to be clean. So there is like probably like half an hour, 1 hour job. You know what I mean? The problem is, what about you start taking the things out, you start cleaning them, and the laptop is dying on you? What about then? How you can explain that to customer, to say, look, I try to clean your liquid damage. I know you came here for a hinge, I know, but probably the customer doesn't even know about liquid damage. Probably he bought the laptop, who knows? and you try to convince him, wait, your laptop has a liquid damage. You can't do it like that. So let's say, realistic speaking, liquid damage job on a working thing, on a working laptop like this one I will say probably like 60. Overheating, it's a very good source of income on a computer shop. And who has a computer shop, they knows. So overheating job usually is 60 pounds. You know what I mean? You can't really do it for free if your laptop didn't came with that specific fault. Now overheating have different meanings, and I probably will have to do again a video. A sitting CPU or GPU to 100 degrees, that's not overheating. Yeah, that's a normal way the laptop works. Overheating means you start doing something heavy like playing games or watching videos and your laptop is shutting down suddenly. Yeah, that's overheating. Can be overheating if you feel it very hot. Now, if you ask me, I never ever seen overheating because of the thermal paste. No, never seen something like that. So, always the overheating comes from a clogged fan. Hello, so where am I? And this time we have a customer job. This is a Lenovo laptop. We don't know yet if it's a nice laptop. Can be Lenovo a nice laptop? I mean, it's i5 10 gen. Now the problem with these laptops, so check here, I plug the charger. You can see the orange light is taking 1.7 amps. You can see that? But pressing the power button, nothing happened, it's just dead. I mean, nothing. Now what can be the problem here? Well, based on the fact the laptop is charging, the ECG most likely is good. So I'm expecting either, I don't know, on the first place, probably a faulty keyboard. The second place, bias issue. Can be. But let's open and check. Okay, so we open the laptop. I can see something there on the ECG pin, but not sure if it's something there or not. You can see. Huh? Onboard RAM, wow, onboard RAM, and the RAM is stuck with that black glue. You can see it? Yeah, that's Lenovo. They never disappoint, never. Okay, let's check the ECG because that's weird. Let me unplug the charger, let me unplug the battery, the BIOS battery, and let's see what do we have there. I mean, no, the ECG is fine. Yeah, I was thinking it's some liquid damage, but it's not. It's no liquid damage. So what can be the problem? Yeah, RAM memory. Replace this RAM memory if you can. Okay, we cannot spot anything wrong with this motherboard. Let's get a multimeter. Let's see. Let's check the coils. Most likely the main power rail is present, the 3.3 is present because the laptop is charging. So what do we have here? Here is good. 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 Wow. Wait. Good. 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 I mean, why everything is good on this laptop? Good. Let's plug the Let's plug the BIOS battery and the main battery. And let's try to focus on the keyboard connector because it's strange. So the AC chip is not reading the power button or is just ignoring the power button? What do you think? Pressing the power button, no, it's not coming on. Okay, let's check the keyboard. Wait a second. I was thinking the 1.7 amps is going to the battery as we have the charging light, but the CPU is hot. Wait, let's unplug the battery. Let's see what this board is taking. Yeah, 800 milliamps. Oh lol. And the power button is working. So holding the power button, let's see if the laptop is switching off. Yeah, it was switching off and switching on again. One more time. Yeah, it goes off and comes back on. Lol, so this laptop is coming on. Oh, everything here is mad hot. Mad hot. Okay, that's strange. Let's try with different RAM memory. So what did you just said? Yeah, the onboard RAM? The onboard RAM? Huh. Okay, let's plug the charger. And it's doing exactly the same. Okay, let's check the voltages. So what do we have here? Here we have nothing. Oh wait, no. 1.8, 0, 0. Okay, so if I have the V core 0, how the CPU is getting hot? Huh? Okay, that's the charging coil. 1.6. 1.6. Never seen 1.6. What can be? Wow! Wow, that's mad hot. I can't believe. So this thingy is mad hot. That one, what I said, 1.6 volts. It's weird. So let me get this straight. Yeah. So basically, we don't have V core, but the CPU is getting hot. And also, this coil has 1.6 and is getting mad hot. So from where the chipset is getting power? Okay, that's the V core, the CPU. But what about the chipset? Why that coil is mad hot? So let me unplug the charger. This is you know what? Okay, this is warm. I can still keep my fingers. But this board here on this side is mad hot. And it's making sense because this coil, it's insanely hot. Good. Let's come with the power supply and the thermal camera. 1.6. So let me understand. Then there should be like 3.3 for the chipset. So actually, the chipset is gone. That's what you're trying to tell me? Because it doesn't make sense. We don't have V core. You know what I mean? The V core is missing. The CPU voltage is missing. So how the CPU is getting hot? Good. Let's lower the voltage. Yeah, 1 volt should be fine. And here, it's taking like 300 milliamps. Yeah, check the chipset. You can see? Yeah, that's the chipset. That's the reason why the CPU is getting hot without having voltage. So all the heat is coming from the chipset. Yeah. Now it's making sense. So there is 1.6, but it should be 3.3. Okay, so actually I was wrong, but that doesn't mean it changed anything. So on the board we have PU 9800 and the coil is PL 9800, right? Okay. So that's the schematic. So we have PL 9800, it's 1.8 volts power rail, which has 1.6, which looks weird. That's why I said, this is looking weird. So let's come with 1.8, just to understand why that power supply has 1.6. 1.8, and it's taking like 2.2 amps, 2.3 amps, doing nothing. Yeah, without clock. You know what I mean? So this chipset is gone. That's the reason why that power supply has only 1.6 volts. Where is the CPU? There. The chipset. Good. So coming with power, check there. I mean, clearly you can see. What do you think? Do you think the manufacturer put all the components there in one corner, on one side? Shorted. Shorted for good. That's the reason why the coil could not keep up with the output. Yeah, sorry, nothing what we can do here. I'm really sorry. Nothing what we can do. Hello, so we are back, and this time we have a nice laptop to fix. It is a nice one or not? Acer Predator, i7 9-gen, 144Hz display, NVIDIA graphics. A proper nice laptop. Now, what's the story with this laptop? High story. Purchased a laptop with no power from eBay. Wow, I mean, it's nothing more risky than buying a gaming laptop, a faulty gaming laptop from eBay. I can't see, I just prefer, just to go on my motorcycle and ride with 300 miles per hour. Probably that's less risky than buying a gaming laptop, no powering on from eBay. I was checking the BQ chip with a multimeter, plug the charger, and in a blown missing component. Okay, the laptop has been worked before inside. Nothing more worse than that. Okay, so let's have a look. Let's open. There's no point to plug this laptop in. Let's try to open, and I mean, the customer is saying he spent some time with the BQ chip. That's no issue. That can be restored. But my concern is if you have like a main power rail shorted, shorted Mosfet, a shorted CPU, GPU, you know what I mean? Chipset, why not? So yeah, I'm just curious to see what is inside. But that's risky, you know what I mean? No powering on, buying a gaming laptop from eBay. I think you have better luck if you just play the lottery. So that's the laptop inside, and it is looking nice. Let's check the main power rail. That's the first thing what we have to check, because otherwise there's no point spending time on this one. 1.7 ohms. I mean, just say it. Just say it. Just say it. You know what I mean? That's the point I was trying to make. The eBay seller, sent the laptop for repair. They told him, you know what, it's a shorted Mosfet, and there's nothing what can be done. Shorted Mosfet on the CPU. And what the seller it will do, it will sell the laptop, obviously, on eBay. So try to don't fall on this trap, yeah? Buying let's say, okay, I want to save some money, so I'll buy a cheap gaming laptop from eBay, broken, so I can fix it. I'm just saying, you know, I'm just saying. Battery, screen. Let's take the heatsink out. Okay, so we took the heatsink out. Okay, let's go with the power supply like usual. Ground. Let's lower the current. Good. 1 volt should be fine. Thermal camera. If you don't have a thermal camera, it's fine. You know, you can just, you know, tap with your finger and find exactly what's getting hot. I mean, I worked so long without a thermal camera. And main power, which is this one. Okay. Good. And we have 2.3 amps. And what is getting hot? The CPU. The CPU. Shorted Mosfet on the CPU. It's even point removing the shorted MOSFET. No. Oh wait, no, someone. So okay, I can see now. So someone took out the coil. You can see. Okay, I can see now. Someone work on the coils. You can see. This one was took off. You can see flags there. Nah, sorry. It's nothing what we can do. You know that CPU took like, it's a big charger, like 10 amps, 20 volts. That's mean like 200 watts. Now, you know, when you came with 19 volts on a CPU which is normally working with 1 volt, let's say from 0.8 up to probably like 1.2 volts, then bad things happen. Okay? I'm gonna stop now because, you know, it's no point. This is a dead CPU. This is a dead CPU. Yeah. Hello. So we are back. And this time we have a nice laptop. What do you think? This is a nice laptop. Lenovo can be a nice laptop? No. This is not a Lenovo. Doesn't look nice and doesn't have stickers, you know? When you see stickers like, you know, Nvidia and Intel, yeah. That can be a nice laptop, but not this one. I'm just joking. It is a nice laptop, yeah? So what the customer is saying, the laptop stopped working after a Windows 11 update. Sounds familiar? It just shows a black screen and power light just repeatedly fades in and out slowly. The laptop was sent back from Lenovo for a different repair issue. The screws on the back panel are still missing from the previous repair. What is it? It surprised me, you know? It's not surprising me. Lenovo is sending the laptops back without the screws. I ship the laptop to you without the screws in. Okay. Okay, so what do we know? We know we have a laptop to repair. Yeah, there are no screws. Let's try to plug a charger first, yeah? Let's just see from where we are starting. Okay, so plug in the charger. Plugging the charger is taking enough. Oh, it is. Yeah, it's charging, right? Yeah, and we have the orange light. 1.3 amps, okay. Let's press the power button. And nothing happened. Wait, we do have, check that. You see the LED on? Let me switch it off. Yeah, now it's off. Oh, oh, and it's coming on by itself. Okay, that's weird because I don't know if this current is taken by laptop or by battery. Let's try and open this. And the laptop is open. Check. Oh, you know, every time when I see onboard RAM, I'm, you know, it's like something is clicking, like in my brain when I see onboard RAM, especially from Lenovo. Okay, that fan, it's very dirty, yeah, and you can see here a lot of dust. But that's not the issue here. So what do I want to do? Is remove the battery. It's mental, you know, from the last time when we fixed that laptop with the RAM memory, with the onboard RAM. Short in the BIOS battery, good. Now let's plug the charger. So plug in the charger and it's like looping. We delete close. Why is looping like that? Check that. 400 0, like 500 0. Why is doing something like that? You know why? Because that can be a power supply protecting itself. Huh? So it is possible to find this fault with our multimeter? Probably not, but at least we can try. Okay, let's see. So we have a chip which is hot there. We have another. Okay, that one is coming on and goes off. Check there. What is there? Okay, that's a chip. It's like, you know, like, okay. Where you will find another dodgy person like me? That power supply, it's weird. Where is it? Where is it? I lost it. Yeah, you can see it now. Check there. Huh? You see, that's the behavior or a power supply which is going on over current. I mean, like something is shorted and the current goes up and the protection kicks in and drop the voltage. Oh, lol. Okay. So check there. Yeah, check there. What do you think is flashing under the heatsink? So I want to pay attention under the heatsink. Not sure if you can see it. What do you think is flashing under the heatsink? The chipset. The chipset. You're right, the chipset. Let's check the resistance with the multimeter. 36 ohms. 28 ohms. It's not looking that unusual. Good. 0 ohms. Okay, this 0 ohms is not good. It doesn't matter from where it's coming. This 0 ohms is not good. 0 ohms again. 1.6 ohms. Okay, so on this point, I believe we have a dead CPU. You can't have 0 ohms. You can't. Even on the gaming laptops, the CPU still have like around 4 ohms. But this one is just, you know, 0 ohms. It's just dead. Let's take the heatsink out. So we took out the heatsink. Let's come with some current, like 0.8 volts on this coil, and it's taking 1.6. Okay, I don't have current. Yay, 3 amps. Check that, 3 amps. What is getting hot? The CPU is dead. We have 2 spots on the CPU, you can see. So this is a dead CPU. Probably even the chipset. Probably even the chipset, it will be dead. Let's see. 19 volts, sorry, 19. Yeah, that's good. Ah, yeah. And yeah, even the chipset is dead. Check on the chipset, it's coming hot like in one corner. You can see? So that's the chipset which is coming hot in one corner. And the CPU which is coming on and goes off on one side. Yeah, nothing what we can do. Nothing what we can do. You can't have a 0 ohm CPU. 0. So we have 0.7 total resistance. But my probe have 0.7, 0.6. So the resistance of the CPU is 0.1 ohm, which is impossible. Yeah, sorry, it's nothing what we can do. Nothing what we can do. I'm really, really, really sorry. Hello, so we are back, and this time we have a very strange job and a very strange laptop. Yeah, I can't say if it's nice or not. So this is a laptop, and the brand name is PC Specialist. That's what the customer is saying. Okay, so what this laptop is doing, we have a picture from the customer. This is a strange fault. Yes, so that's the picture we have from the customer. So check there, you can see here around the M2 drive, or what is here? What is the battery connector? Not sure, but you can see the black mark. So something is burned there. So very possible we are dealing with burn layers. Now let's open this one quickly and let's try to have a look before we are plugging the power in. Okay, so that's the laptop inside, and we can see the battery is disconnected. You can see the chipset there. Ah, look, yeah, you can see the burn mark. Yeah, you can see it's there. Here, let's check under the microscope. So what is that looking for you? Liquid? It's a big hole on the motherboard. Okay, and someone put plastic. Okay, yeah, got it. So it's a hole on the motherboard, and someone put plastic there. But the hole is still the other side of the board. I can see on the other side of the board. You can believe that? So this one is to the other side of the board. That sucks, you know. Let's check the main power rail, which probably it is shorted. But let's make it clear. So where is the main power rail? Here. Oh, sorry. So the main power rail, 1 ohm. I mean 0.3, 0.4 ohms. You know, the battery connector doesn't have anything to do with the burn motherboard, because from the battery you have a Mosfet, and then the battery power is coming to the main power rail. But in this case, the main power rail is shorted. That means that track is actually the main power rail itself. So I'll say let's take the board out to have a look on the other side and see if we can do anything. Good. Let's leave the laptop on one side and let's try to focus on the motherboard. Wow. Okay, so someone worked hard here on this board. Yeah, okay, I can see now. Yeah, it is looking bad. So what's that Mosfet is doing? Let's see. We can't see on this side. Huh. I believe these have something to do with the charging, right? Must be the charging power supply. I mean, don't get me wrong, I'm not looking to make this laptop like new, but at least if the customer can use it, you know, with the charger plugged in without the battery, and we still did something. Not sure what is this. Is plastic. I believe what you see here is plastic, it's not flux. And the board, you see the hole, you see this hole is going on the other side of the motherboard, this one. I mean, it's nothing what we can do here. I'm just trying to remove the short from the main power rail, and I'm curious from where it's coming. So this probably is the main power rail. Let's check together. And it's shorted. You can see it's 1.8 ohms. I should remove it. So how this is going to coils? 1 second, lol. Then this is the charging coil. Yeah, this one. This one is the coil that is charging the battery. That means this coil must be a power supply. This one. And the problem is we don't know what this power supply is doing. Huh? So how is it? That's a nice hole, right? So how is it looking to you? Hmm? Like a volcano, or like, you know, the rock on the mountains? Hmm. Well, let's go with current to see if we still have short. So coming with current on the same spot here, 110 milliamps. Okay, we are close, but not there yet. We are close. You see any alcohol movement? Because I can't. Okay, let's higher the voltage. Where? On the other side or here? Here, right? Oh yeah, there. Yeah, you can see there between the layers. Yeah, there. if he cannot fix it, how do I send a motherboard with a hole back to the customer? Pretty weird to explain something like that. I mean, you can explain something like that to someone who knows. But someone who doesn't know, it's kind of strange. So what do you think? We still have short? Let's check. It's taking no power. Check that on the screen. So the short is gone. 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 I mean, not sure what to say. I don't know what that power supply is doing. Nah, not sure. So I will say, let's see, right? So I have to plug. You know what? This motherboard. Check how small it is. I mean, obviously, when you put everything very close, even the power rails are close, the tracks are close, and the probability for something like this to happen is extremely high. Let's plug the charger. So 19 volts, a little bit of current, right? Plug in the charger, and it's short. Lol, what is that? What smoked? This was semiconductor. This was not the board, it was a semiconductor. So something blew up. What is that? That chip blew up? Really? That chip has a hole on it. Check that. This one has a hole. You can see? That's a hole. BQ chip. So the BQ chip has a hole on it. Do you really believe this chipset is still good? Is here any hope on this repair? So what is smoking? The board? The board is smoking. Lol. Lol, something there. So it's not done yet? It's taking 160 milliamps. So what is taking? My dead BQ chip or the whole? Probably the dead BQ chip is taking the power, right? Why the EC chip is hot? Why the EC chip is... Oh, that's sick. Yeah, has 0 ohms. So the AC chip is dead, the BQ chip is dead, and we have a hole on the motherboard. But at least it's not shorted anymore. No, it's nothing what we can do here. I mean, I can't really be that crazy to replace the AC chip and the BQ chip and I hope actually, you know, I mean, if there was a power supply, okay, I can we can do some, we can add a power supply, yeah, like external power supply. I can do it, but when we have so many problems, yeah. Sorry. I mean, it's not even point. Let's use alcohol. Yeah, we can check. So the AIO chip has 2 ohms. You can see on the screen 2 ohms, 5 ohms, 2 ohms. The AC chip is dead. The AC chip is dead. The BQ chip has a hole on it, and we have a hole on the motherboard. So what you'll do in this case? Indeed, the motherboard is not shorted anymore, but the motherboard is taking 150 milliamps, which we know and we learn actually is very bad. I'm gonna stop now because it's kind of pointless right now. Hello, so we are back, and this time we have a customer job. This is a nice laptop. Lenovo Yoga i7 Iris graphics, and the customer is saying it powers on but never gets any picture on the screen or to an external monitor. The battery charges fully, so he thinks it's a corrupted BIOS. So what do you think? We can help this customer? The charger is plugged in, it's taking around 2 amps, you can see that. Pressing the power button, and you can see the lights on the keyboard. Yeah, you can see the lights on the keyboard. So the laptop, it is coming on, but no picture on the screen, nothing. Caps lock is not responding. That means probably the system is frozen. So what do you think about this laptop? Huh? No, it's not working. Can be a BIOS? Not sure. But let's open the laptop and check a little bit inside. Now what do I want to check is the coils, yeah? Because no picture on the screen. Can be DC chip, can be RAM memory, can be CPU, can be chipset. Are a lot of reasons. Yeah, I can feel the heatsink warm, so how you will approach a repair like this? Someone is trying to save the thermal paste. Here is 1.8. Here it's 1.7. But why this CPU is getting that hot? Let's check with the thermal camera. Now check the chipset. That's not supposed to happen. So you understand this laptop is off. I'll turn it on. Now the laptop is on. And clearly the CPU is hotter than the chipset. So the CPU looks fine. It's shutting down because of high temperature. But the chipset is not normal to take that kind of current when the laptop is off. Yeah? So this is a dead chipset. There's nothing what you can do. You can clearly see it's taking a lot of power. Like what, like 42 degrees there? And it's on one side, that's the thing. I mean, even if I cool down the chipset, I can cool it down. Now check there. It's getting hot. So once I take the heatsink, you can see the chipset is gone. Nothing what we can do in this case. That chipset. Hello. So we're back, and this time we have a customer job. This is a nice laptop. So check here, yeah? Acer Ryzen 7 and Radeon graphics. I mean, you know, those laptops, like small laptops, powerful, you know, like a beast. This is a nice one, I told you, yeah? So what this is doing, the customer is saying, is taking no power, it's not coming on, nothing, yeah? Let's try to press the power button. Pressing the power button, nothing happened. Let me plug a charger. Okay, ready? So I got the charger, plug in the charger. So how much current is taking this laptop? Yeah, check on the power supply. And you'll say, sorry, it's taking zero, it's taking no current at all, right? That's what you'll say. You see? That's why a linear power supply is good. I can't show you. I don't think I can show you. No, I can't show you, but I can record with my phone, yeah? So check here, yeah? Check here. All I'm trying to tell you how you can diagnose a laptop just, by checking the power supply. You can see? So basically what you see there is the current LED is flashing. You can see it? You can see the current LED flashing, but it's showing no current at all, but it's flashing. So what that flash means? That means the current goes over what you set up on the power supply. On my power supply right now, it's about 3 amps. So the current goes for a very short period of time. You can't see it there, yeah? Goes over 3 amps. And you say, no, sorry, it's zero. No, I'm telling you, it's over 3 amps, but you can't see it because it's too fast. It's like a spike. It's taking currents in spikes. So what does mean? Does mean it's a power supply or a input power circuit, which is in the circuit is trying to push the power forward, but it's a short forward. And on that moment, it will cut the power down. It will start the power, the current sensor, it will sense the current is going too much, and the Mosfet, it will cut the power down. That's the explanation of that LED from the power supply, yeah? Good. Now let's open the laptop quickly and try to figure it out why something is getting over 3 amps. Okay, so the laptop is open. And check here, it's a nice motherboard. Someone opened the laptop because I can see prints. But can you spot anything wrong on this motherboard? That cable is not plugged in properly. So I believe someone opened this laptop. Check that cable. You can see that cable. You think that's the problem? Probably not. Probably not. Probably that's not a problem. Yeah. So now the cable is plugged in properly. Yeah, it's interesting. No one took out the battery. Okay, that's interesting. But someone played with that cable. So we disconnect the battery. Let's plug the charger. It's doing exactly the same thing. Exactly the same thing. Okay, so what we are checking first? We have the multimeter on screen, right? Yeah. So first thing what you will check is the main power rail, because every power supply is connected on the main power rail. So if one power supply is shorted, all power supplies, it will be shorted, okay? So ground, the main power rail, you can see the capacitor, you can see Mosfet, you can see capacitors here, you can see them. 0, 0. The main power rail is shorted to ground. That's the reason why you've seen that LED on the power supply. Okay, so how we can find a fault like that? Very simple with the thermal camera. It's very simple. If you don't have a thermal camera, you do exactly what Sorin did like for about 10 years. Yeah, you come with some current the same way, and try with this side of the finger because it's sensitive. Yeah, and try and yeah, you'll get burned, but it is what it is. But don't worry, you don't have to spend money. You can, just tap it and you'll find what is getting hot. Now I'll lower the voltage on the power supply because it is possible to be like a shorted Mosfet, can be. Yeah, so low voltage, some current there. And I will come with the power supply same on those capacitors from here. So here we have, check on the voltage. Yeah, so here is ground and here is plus. and it's taking around 300 milliamps, so the short is not very short. I will raise the voltage. Yeah, 700 milliamps. So the short resistance is very high, so possible to have like a Mosfet. I can't see anything. You think I can be wrong? That's interesting. What is that? Wait, what's that? So that thingy is taking 700 milliamps. This one, okay, that's bad. That's bad. I believe that one is the 3.3 volts power supply, but let's have a look under the microscope. Okay, not sure what happened here, yeah? So pay attention. So someone worked here, right? But also, we can see liquid damage. You can see the liquid damage there? I mean, clearly that is liquid damage. So what you see here on the motherboard, this is liquid damage. You can see it? Okay, I think someone got it wrong. So this is a resistor, right? And here I suppose has to be a capacitor. So someone use a resistor instead of a capacitor? Not sure about that, but first let's clean, because we can see here is some liquid damage. Okay, so we clean. No, actually it's not a capacitor, it's a PL, yeah? So PL stands for inductor. So this inductor is right. Okay, let's see what this chip is doing. Let's see the output of this chip. So we have the input here, and it's like 0 ohms, okay. And we have the output, which is like 1.4 ohms, and that's bad. 1.4 ohms. Okay, that's bad. Okay, so let's remove this chip first, and let's see what's going on there. So we remove the chip, but my problem is what is on this coil and has 1 ohm. You see, that's my problem. So even if I replace the chip, and it will still be 1 ohm there. Yeah, so the main power is not shorted anymore, you can see. I mean, I can go back to those capacitors here. Oh wait, so someone removed the capacitors because I can see flux. So someone actually removed every capacitor. Okay. Yeah. So it's not short anymore. Yeah, so probably someone removed the capacitor and they found out, wait, here is a short on the output of this chip. So even if we are replacing the chip, it will still be dead. Okay, what that chip is doing? That's a good question. So what that chip is doing? We're gonna find out together what that chip is doing. Let's see the CPU. Yeah, the CPU is gone. The CPU is gone. Yeah, the problem is I can't fix this. I can't fix the CPU. Yeah, I'm really sorry for the customer. So basically everything started for a drop of water. Yeah, that's what it was there, a drop of water on that chip. And from that point, the CPU died, the chip died, and yeah. Hello, so we're back. And this time, we have a nice laptop. We have a Alienware, a new one, i7. Huh? What do you think about this one? This is a proper nice laptop. The laptop has been opened before. I can see on the screws, you can see, so someone opened this before. So what the customer is saying about this laptop? The customer is saying, sorry, I have like 3 laptops I want to send you. Can I send them? And I said, yeah, you can send them. That's all what we know about this job. Yeah, this is an old customer. I believe it's a computer shop. Now let's plug the charger. Plug in the charger. And it's taking like 30 milliamps. You know what? 30 milliamps is a little bit too high. I mean, I can understand 10, I can understand 20, but 30 is kind of high. Now pressing the power button, nothing happened. Okay? Nothing. It just did. Now let's open the laptop quickly and have a look inside. Okay, so the back cover is removed. This connector is not plugged in, the battery is unplugged. That's okay. I mean, this is a small board. Or are multi-boards. We have boards here, boards down. This is liquid. I can see some spots here. Okay, let's check the main power rail. That's what we are checking first, yeah? I mean, they have strange color. Check here. I mean, it looks like, you know, like some liquid damage. You see the color of this capacitor? Look at the color of those capacitors. Yeah, so probably this was a liquid damage job. MOSFETs everywhere. We have 19 volts. Lol. Okay, so those are the inputs MOSFETs. You can see they have like 2 in the parallel mode, yeah? So you have 2 and 2. The gate, yeah, the gate is high. So the main power rail is present. Okay, so we took the board out. And even on this side was liquid damage. I mean, I can see it without microscope. Well, let's have a look. I mean, that MOSFET is blow up. Lol. So here it was probably a capacitor, right? Dodgy people, I don't understand why they don't replace the capacitor. They didn't replace it, they just remove it. This MOSFET is blow up. You can see it has a hole on it. You can see it? So this MOSFET is gone. Check here. It has a hole on it. Which is bad. That means the laptop was working when it was the liquid damage. Let's see the output of that coil. 4 ohms. Why 4 ohms? It's near to the chipset. If it's the chipset, we are wasting time. You know what I mean? We have 4 ohms. Okay, so we took the heatsink out. Wow, that's a serious GPU. You can see it. Check that. Okay, so let's see what the 4 ohms power rail is doing. I mean, I expect like 4 ohms near to the CPU, but not here. So, let's lower the voltage. Yeah, that's fine. We have some current. Well, it takes like 5 amps. That's crazy. Check that. The chipset is taking 5 amps. That's crazy. What a waste of time. Yeah, it can be replaced. Kind of easily, but you won't find another chipset. Okay, I'm really sorry. I will stop here because there's nothing what I can do with this one. I was hoping, to have like a good video with this new Alienware. Where is the IO chip? Yeah, the IO chip is here. Yeah, the IO chip is here. Hello, so we're back, and this time we have a nice laptop to repair. So check here, i7. No, I didn't see that. i7 and NVIDIA graphics. Looks like the customer left a chip here. Let's open the laptop quickly and have a look inside. Okay, I just checked the customer email. He said he replaced that chip. That's the original chip. He replaced it, and the chip is still getting hot. Okay, so we open the laptop. So the chip is here. You can see the customer made a mark. Now the customer said he replaced the chip and the chip is still getting hot. Now the easiest way, before even replacing the chip, is to check the output of that coil. So what is the output of the coil? It's not sure. 34 ohms. Okay, let me plug a charger. So this is a HP. Okay, we do have a HP blue pin. Let's raise the voltage. So plug in the charger and it's taking 20 milliamps. Let's check the output of that coil. And it's 0 volts. So why the customer is saying the chip is getting hot? I mean, what is here? Huh? Oh, this is just something which land here. Okay. Okay. So let's focus on this power supply, which the customer said he replaced it and it's still getting hot. Let's try to find out what it's doing, what this power supply is doing. And with 20 milliamps, I can't see how this power supply, it will get hot. Maybe it can get warm, but not hot. Pressing the power button, the laptop is coming on, and it's taking only 50 milliamps. And the chipset is getting hot in one corner. Okay, that makes sense. The chip is not getting hot, it's getting warm. 3.3. I mean, the chip is working fine. Yeah, 1 volt. 3.3. Okay, that makes sense. If that chip got burned, then probably the chip burned the chipset. Yeah. That's the reason why. Yeah, you can see. I checked that. And clearly that's a faulty chipset. Hello. So we are kind of back. We have a nice laptop to fix. This is a customer job. So check here. NVIDIA graphics. Wait, NVIDIA and AMD Radeon? They are switching graphics? Yeah, possible. And Ryzen 7. The problem with this one, it is coming on, you can see, but it's no picture on the screen. You can see the backlight on the keyboard. Not sure if you can see it. Yeah, you can see it now. But it's no picture on the screen. I did check with the charger. It's not working with my universal charger. But obviously it looks like the laptop is charging and it's coming on onto the battery. So let's quickly open this laptop and try to figure it out what is wrong there. That's a nice board. The customer said he tried already the BIOS. So I'm not sure what we can try. Okay, it's not looking bad. Let's check the coils here. Let's unplug. Actually, no. We don't have to unplug the battery. Okay, that's the VRAM and it's good. That's the GPU, CPU, boosting coil. Okay, all looks good. Now let's try. Let me grab the thermal camera. Maybe we can spot something. 1 second. What is on that connector? Let's check together. I just see now that connector. What is that? Huh? You know, the ribbon cable is looking low. The ribbon cable is broken. Check that. That's the ribbon cable. Someone snapped the ribbon cable. So how we can fix something like that? I mean, we can't because this is broken. The thing is, what if we are, you know, replacing the cable, the connector? How we can know if the CPU is still good or not? How you can obviously this is a short on the connector, yeah, on the screen connector. How you can know if it will work after we are replacing the screen connector? Because it's not working on the HDMI. That's what the customer said. I mean, not sure if someone burned it or what. I mean, someone clearly broke that cable. But who broke that cable didn't see the connector, or what happened here? This is not shorted on 19 volts. This is shorted probably on the 3.3. Yeah, check here. So you have the 3.3 power line, which is coming here. The problem is, all I want to see is here. Do we still have picture? Because if the GPU is dead, you know, it's nothing what we can do. But I cannot be sure if the GPU is dead till the moment actually I'm checking what's going on here. We don't need backlight, so don't get me wrong. Where is the ribbon cable broken? I don't care. I care about the 3.3 and data line, so basically this part of the connector. If I'm able to see, you know, the picture without the backlight, then I know I will be fine. On the other hand, you know, any, you know, soldering wires, it looks dodgy. I'm not sure if the customer will understand this kind of dodginess. You know, I'll speak with the customer for a ribbon cable. I don't know what to do because I need the connector also. Let me think a little bit. Hello, so we are back. Saturday, and it's a beautiful weather outside. You can see the sun shining nicely there. So what do we have today? We have a nice laptop. And when I say a nice laptop, check here, yeah? Acer Predator, i7 10 Gen, NVIDIA graphics, 144Hz display, This is a proper nice one. So what's the problem with this one? Not coming on. So that's what the customer said, not charging and not coming on. Okay, let's open this laptop quickly and let's see what we have inside. I mean, on the gaming laptops, we can have two things, yeah? Shorted MOSFET, shorted capacitors. Only that, yeah? If the customer is lucky, it can be like a shorted capacitor. If he's unlucky, mostly unlucky, it will be like a shorted MOSFET, that CPU, that GPU. You know the story with the gaming laptops. Not charging, yeah? Have in mind, yeah? Let's say, okay, maybe something else. Maybe it's not a MOSFET or capacitor. Okay, but it's not charging. Yeah, that means probably the main power rail is shorted. And that's a good reason why the laptop it will not charge. Okay, so the laptop is open. Someone fixed it before? For some reason it's looking like someone tried to fix it. Let's disconnect the battery. Let's take the multimeter because now is the moment. You can't see because of the sun. Better now? So clearly someone opened this laptop before. You can see. Now let's get the multimeter. And let's check the main power rail. The main power rail. Yeah, we can check we have capacitors. 0 ohms. We have here a test point, so this is the main power rail. 0 ohms. You see exactly what I told you. Now let's get out the heatsink and see what actually is shorted here. Okay, so the heatsink is out. Let me grab the thermal camera. Let's get the power supply. Let me lower the voltage. Yeah, 0.9 should be fine. We are coming with the voltage of the main power rail. You see we have here two MOSFETs. After those two MOSFETs, it's your main power rail. And it's taking 2.5 amps. And what do you think is there? The CPU. Yeah, you're right. And check the CPU. It has like a dot in the CPU. So which one is shorted? Which MOSFET? This one. So this MOSFET is gone. This one is like I can see on the thermal camera. It's warm. Okay, let's quickly remove the MOSFET. After we are removing the MOSFET, the laptop should come on. Yeah, you can see clearly. Check here. Yeah, someone already play here. You can see. Look, solder. And actually, the MOSFET has been replaced. Yeah, so we removed the MOSFET. Yeah, someone already removed this MOSFET before. So what about now? The main power rail is still shorted. Let's see. No short on the main power rail, you can see. Let me unplug the battery. Okay, now it's fine. Pressing the power button. And the laptop is coming on. Check that, 1 amp. And it's going off, right? On. Yeah, dead. It's still taking 1 amp, but no picture on the screen. So it is coming on, but no picture on the screen. Hello, so we're back, and this time we have a customer job here, yeah? So this is a nice laptop. Check here. i3 A-Gen. The problem is with this one is dead. Let's plug the charger. With the charger plugged in, check here on the meter. 90 volts, so it's negotiating the voltage, but it's only 0.1, like 100 milliamps, 130 milliamps, which is not really a good current. Pressing the power button, nothing happened. Okay, good. Let's open this quickly and see if we can spot something. Okay, so the laptop is open. And it's looking good inside. Okay, someone disconnect the battery, disconnect the BIOS battery. No hard drive. Okay, let's plug the charger. And what we are checking first, the main power rail, right? We should have 19. Do we have 19? We have 0. No, we have 9.2. 9.2. 1.2. 5 volts. 0. 1.6. Wait, why this main power rail has like 9 volts? I mean, it's making sense if you have like a special power supply to create the main power rail, yeah? Because you have two types of laptops. The laptops, they have, the main power rail is coming from the charging port, 19 volts. And the second type you have has a special coil, which is creating from that 19 volts is creating the another main power rail with a lower voltage, usually the battery voltage. Why the battery was unplugged? Oh, let's plug the battery. So plugging the battery, nothing changed. Oh yeah, it's this. Look, it's 0.2, 0.3. It's going up. It's charging. Lol, the battery is charging. 1.9 amps. Check here. 1.9. And the battery voltage 0.7, 10.7. So the battery is charging fine. 10.8. 10.9. Yeah. So the main power LED is present. The problem is the laptop is not coming on. That's the issue with this one. Nothing is not coming on. Okay, let's check. The 3.3 clearly is present, because otherwise we will not have 19 negotiated on the USB port. Wait, the laptop is on? We have light on the power button? Can I switch it off? Yeah, I can. But it's not switching off. Wait, but the laptop is still off. Or it's not? It's coming on. Let me grab the thermal camera, because I don't understand what's going on here. Let me unplug the battery, because it's confusing with the battery. So without the battery, we have 100 milliamps, and this is on. Let's see. Okay, that was from the charging. Oh, what chip is that? This one. Okay, that one I think is creating the 5 volts. and otherwise it's looking good. Go, let's unplug the charger. Let's switch to beeping and let's check the coils. So here we have LOL 3 volts. How we can have 3 volts here? Oh, sorry, 3 ohms. Good. Here we have 19. Here we have 5, 6. Yeah, 6 ohms. And here we have 7. So those are the V cores. This is the boosting, the V core. This, no idea. And this one, most likely is the chipset. So the chipset is gone on this model. .3.2, 1 second. This has 3.2 also. 3.2. Which is the RAM power supply. So I have a problem with this one with 3.2 ohms and this one with 3.4 ohms. Yeah. So let's take the heatsink out and see which one is the RAM and which one is the chipset. So I'll come with the power supply, low voltage. Yeah, 0.8 should be fine. So coming here is taking like 2.4 amps. Lol. That's crazy. What do you think is taking 2.4 amps? The corner of the chipset. Can you see it? Yeah. What about this one? 3.2 ohms. It's taking same amount of current. This is the chip. This is the chipset. This is actually the probably this is the chipset power supply, and this is the other part of the chipset. Yeah, it's gone. What a waste of time. I seen that from the moment when I seen the laptop on, but it's not taking current. You know, actually, that's the chipset.